everyone, and welcome to today's session. The topic for the webinar is why machine learning should be considered for digital transformation. A recorded version of this webinar will be available on Navkara YouTube channel. We would like to hear from you at the end of the webinar. If you have any questions, please write to us in the chat window. This webinar is hosted by Navkara Consultancy. We are a team of 4 who will be the speakers of this webinar. Navkara is a leading global consulting company that is specialized in digital transformation. We serve clients across spectrum of industries, including healthcare, public sector, federal, and commercial. From this presentation, you will understand the following concepts. What is machine learning? History of machine learning, types of machine learning, what is a confusion matrix, where and how can machine learning be applied in various sectors, and what is a neural network. Tom is a 3-year-old child who is very excited for his first day at kindergarten school. His mom had prepared a cup of milk for him while he was getting ready. As soon as he saw the cup of milk, he took a sip from it and unfortunately burnt his tongue. His mom explained that the milk was very hot and that's why it's always important to check the of milk before sipping. After his day at school, she gave him an ice cream. As he was enjoying it, his mom explained him that the temperature of the ice cream is very low, because of which it is cold. The next day, Tom somehow managed to lit a matchstick. As soon as his mother saw him, she told him that if he touches the stick, he would burn his finger, just like he burnt his tongue the other day. He quickly understood and put it away. From the story, we can Tom had a bad experience and learned his lesson. Here, there is just a single feature, that is temperature. In the same way, the ability of machines to learn from their past experience on multiple attributes and improve their decision making over time without being programmed to do is machine learning. Let's talk about the history of machine learning. The concept of machine learning came into picture when Alan Turing published an article answering the question, can machines think like humans? He proposed a hypothesis stating that machines that succeeded in convincing humans that it is not indeed a machine would have achieved artificial intelligence. The experiment goes like this. In the Turing test, the interrogator is given the task of trying to determine which player, A or B, is a computer and which is a human. The interrogator would ask the same question to AI as well as to the human, and if he is able to distinguish between both, then AI would lose. If he cannot distinguish, then AI would win. According to Herbert Simon, machine learning is concerned with computer programs that automatically improve their performance through experience. Difference between traditional programming and machine learning. Traditional programming refers to any manually created program that uses input data and runs on computer to produce the output. While in machine learning, the input data and the output data are fed to an algorithm to create a program. This yields powerful insights that can be used to predict future outcomes. The logic generated is what makes it machine learning. Let's look into the example shown alongside. In traditional learning, the user has manually coded the logic of x plus 1 and the input given is 5. So the computer displays the output as 6. While in machine learning, the input or independent variable is 5 and the dependent variable or output passed is 6. So the algorithm understands the logic, and next time when the user passes any input, the algorithm can predict the output using the same logic. There are three types of machine learning: supervised learning, reinforcement learning, and unsupervised learning. Our next speaker, Melito Salvi, will be talking more about supervised learning.
Supervised learning. Supervised learning, as the name suggests, works under supervision. That is, it's learning in which machine is trained with data which is well labeled and then predicts with the help of the labeled data set. But what is labeled data set? Data for which you already know the target answer is called a labeled data. Like I show you an image and tell you that it's a dog, then it's a labeled data. While if I show you an image without telling you what exactly it is, then it's an unlabeled data. Now let's see. We have images which are labeled as spoon or knife. We then feed it to the machine, which analyzes and learns the association of these images with its labels based on its features such as shape, size, sharpness, etc. Now, when a new image is fed to the machine without any label, with the help of the past data, the machine is able to predict accurately and tell that it's a spoon. Hence, in supervised machine learning, the algorithm teaches the model to learn from the labeled example that we provide. So, supervised machine learning can be further divided into classification and regression. There is an important difference between classification and regression. Basically, classification is about predicting a label or a class, whereas regression is about predicting a continuous quantity. Now, let's say that you have to classify your emails into two different routes. So, you basically will be labeling our emails as spam and non spam mails. For this kind of problem where we have to assign our input data into different classes, we make use of classification algorithms. On the other hand, regression is used to predict a continuous quantity. Now, a continuous variable is a variable that has infinite number of possibilities. For example, a person's weight. So someone could weigh 170 pounds, or they could be 170.10 pounds or 170.110 pounds. Now, the number of possibilities for weight are limitless, and this is exactly what a continuous variable is. So, regression is a predictive analysis used to predict continuous variables. Here, you don't have to label data in different classes. Instead, you have to predict a final outcome, like let's say that you want to predict the price of a stock over a period of time. For such problems, you can make use of regression algorithms. The different types of models or algorithms that come under supervised machine learning are these. I now hand over the session to Ms. Bincy Thomas, who will be sharing her expertise on the topic confusion matrix.
Confusion matrix is used for evaluating the performance of a classification model. The matrix compares actual target variables with those predicted by machine learning model. This gives us a holistic view of how well a classification model is performing and what kind of error it is making. Confusion matrix is a table with four different combinations of predicted and actual value. The target variable has two values, positive or negative. It can also be referred as 0 or 1. 0 for negative, 1 for positive. The column represents the actual values of target variable and rows represents the predicted value for target variable. TP, true positive, is a case where actual value was positive and the model predicted a positive value. Say, for example, if a COVID affected person goes for getting tested and the test reports are positive, then it's a true positive case. True negative, TN, is a case where actual value is negative and the model predicted a negative value. Say, for example, a person who doesn't have COVID goes for getting tested and the test reports shows up to be negative, then it's a true negative case. Similarly, we have false positive, FP. It is a case where actual value of an experiment is negative, but the model predicted a positive value for it. Say, for example, a person doesn't have COVID, but the test report shows positive value. then it is a false positive case. Similarly, we have false negative, FN. It is a case where actual value was positive, but the model predicted a negative value. Say, for example, a person is COVID affected, but the test report shows up to be negative, then it's a false negative case. In this way, confusion matrix helps us to count the correct and incorrect classifications. Now, the next speaker is Shamil.
Unsupervised learning. Unsupervised learning is a self-learning technique in which the system has to discover the features of the input data by its own, and no prior set of categories are used. It deals with the unlabeled data. The image on the right is an example of supervised learning where the cars are labeled. The image on the left is an example of unsupervised learning where the cars or any other objects are not labeled. Supervised learning allows you to collect data or produce a data output from the previous experience. Unsupervised machine learning helps you to find all kinds of unknown patterns in data. In the image, data points having similar features are grouped or clustered together. Therefore, data points in orange color have similar features. Similarly, data points in yellow and green color have similar features. Some of the frequently used algorithms. First is k-means clustering. K-means is a centroid-based algorithm or a mean-based algorithm where we calculate the means to assign a point to a cluster. Second is principal component analysis, or PCA, is a dimensionality reduction method that is often used to reduce the dimensionality of large data sets by transforming a large set of variables into a smaller one that still contains most of the information in the large set. The essence of the data is captured in a few principal components, which themselves convey the variation in the data. In the image, we observe that the variables on X and Y axis are transformed into a new set of variables, PCA1 and PCA2, which are linear combinations of variables on X and Y axis. First principal component, PCA1, captures most of the data. Second principal component, PCA2, captures the variance in the data, which are not captured by PCA1. Reinforcement learning. Reinforcement learning is an area of machine learning which is about taking suitable action to maximize reward in a particular situation. Reinforcement learning differs from supervised learning in not needing labeled input output pairs and in not needing suboptimal actions to be explicitly corrected. In this picture, we observe there is an agent and an environment. Agent performs an action in the environment. For every action, a positive or negative reward can be defined. These rewards serve as remarks from which a model can learn from mistakes and continue to improve with each iteration. The goal of reinforcement learning is to train an agent to complete a task within an uncertain environment. Our next speaker, Ms. Bincy, is going to speak about applications of machine learning.
Application of machine learning in different domains like retail sector, telecom companies, healthcare, marketing and sales, transportation, government agencies, financial services, etc. helps to boost their business and for coming up with new strategies for improving their business and the services which they provide. Moving forward, I will be giving some examples of problems that can be solved using supervised learning, unsupervised learning, and reinforcement learning techniques. Machine learning in banking sector. Consider we have a data set containing customers' details like customers' income, education, minimum account balance maintained, occupation, credit history, etc., which is collected by the customers when they fill the application form. The bank wants to automate their loan eligibility process. Then, by using supervised learning techniques, we can categorize customers into categories: eligible for loan and not eligible. Based on this segmentation, bank can target their customers. Supervised learning based models like logistic regression can be used to classify the customers based on their background study. Decision tree will graphically classify the customers based on the features. Using random forest, we can get multiple trees on various subsets, which will improve the predictive accuracy of the model. Machine learning in e-commerce. Famous online retailers like Amazon, Myntra, etc. recommends us relevant products based on our purchasing history. For example, customers who purchase smartphones are more likely to purchase earphones and power banks, etc. It works on if and then scenario. If coffee, then sugar. Using machine learning, these retailers get to know the customer's purchasing behavior, and based on this, they recommend similar products to the customers. Unsupervised learning-based models like market basket analysis is used to identify the strength of association between pairs of products purchased together and to identify the pattern of co-occurrence between the products. A priori algorithm uses prior knowledge of frequently bought data set that occurred together. Association rule basically is to discover the relationship between the variable. Example, number of items which are bought together. Using this method, we can analyze the customer's purchasing behavior. Application of machine learning. Application of machine learning in reinforcement. On YouTube, users' preferences changes based on the huge amount of data which is available on YouTube. So, based on the users' review, likes, survey, and subscriptions, YouTube recommend system tries to sort through the large collection of data and tries to filter contents which are more relevant to the customer and the customers who may be interested in that content based on their action. Using reinforcement learning, it can keep a track on users' return behavior and it continuously learns the pattern of behavior and actions performed by the users. Now, my colleague Anne Maria will continue with neural networks.
Neural network. Neural network, as the name suggests, is inspired by the brain's biological neural network. Neural networks are parallel computing devices, which is basically an attempt to make a computer model of the brain. The main objective is to develop a system to perform various computational tasks faster than the traditional system. Neural network is also known as artificial neural network. ANN consists of input layer, hidden layer, and output layer. Let me introduce neural network using an example. Sam and his mother visits a painting exhibition. Looking at the fascinating art, he gets lost and approaches the authorities so that he can find his mother. They ask him for details like color and length of her hair, color of her dress, skin color, height, and her picture. They start to look for his mother. They came across a lady whose color of dress matched but did not match with other details. Then they came across people whose hair length was short but did not wear black dress. They even found a lady whose hair was black and short, who wore a black dress, and even her height was medium. But Sam told that she was not his mother. Finally, after searching through the crowd, they finds a lady who matched all criteria. And Sam yelled out saying, "Yay, that's my mother." And Sam was happy. The input layer of a neural network is composed of artificial input neurons and brings the initial data into the system for further processing by subsequent layers of artificial neurons. The input layer is the very beginning of the workflow for the artificial neural network. From the example, input features are the features like length, color of hair, color of dress, face, etc. A hidden layer in an artificial neural network is a layer between the input layer and the output layer, where artificial neurons take in a set of weighted inputs and produce an output through an activation function. Let's understand weight from Sam's example. The feature color of dress, color of hair, length of hair, height will have comparatively low weightage because There could be many people wearing color black, having black short hair, and medium height. The feature having the most weight would be the face because that's what distinguishes Sam's mother from the rest. The output layer in an artificial neural network is the last layer of the neuron that produces given output for the program. There is also something known as activation function in neural network. Activation function results in an output signal only when an input signal exceeding a specific threshold value comes as an input. It is similar in behavior to the biological neural network, which transmits the signal only when the total input signal meets the firing threshold. For example, if we smell something pleasant, like freshly baked cake, certain neurons in our brain fire and becomes activated. If we smell something unpleasant, like spoiled fruits, this will cause other neurons in our brain to fire. So within our brain, certain neurons is either firing or not. This could be represented by 0 for not firing and 1 for firing. In this example, the image is divided into pixels and the associated pixel gets activated and the output layer with the highest value is the final prediction. The input here is 9 and after it passes through the neural network, the pixels associated with the number 9 gets activated and the predicted output is 9.
So the question remains why machine learning should be considered for digital transformation. Digital transformation is about re engineering and rebuilding your business in the era of cloud, mobile, information technology, analytics, machine learning, and artificial intelligence to improve processes, customer experiences, and decision outcomes. This definition shows why machine learning is more relevant to digital transformation because it can automate time consuming tasks so that people and businesses can innovate.
If you have any questions, kindly mail to info@navkara.com. Here we complete our presentation and I hope you have understood the basic concepts. Thank you for being a wonderful audience.